iron so that reaction will be carried out so that we are going to get the products aluminum oxide plus iron. So till now, if you notice it, majority of the reactions I taught you, metals only reacting. Is it yes or no, guys? Please respond. Yes, please. Now, I want to tell you one important reaction. How many of you know welding, guys? Do you all know welding? Welding.
Yes, sir.
Yeah,
Yes, sir.
welding. So now let us discuss that reaction also. So now I'm going to teach you one very important reaction. That is what? Thermite reaction. Just what we studied just now. So this is what we used to call as thermite reaction. In this thermite reaction, we are going to get iron. In which state, guys? Iron in which state? Liquid. So this is only called as molten iron, we can say. So in this case, we are going to get large amount of heat. Understanding? So that is why this reaction is called as thermite reaction. What we used to call?
Thermite reaction.
Thermite reaction. Okay. Very, very important one. Or we can say thermite welding. Okay. In railways and all, when they are constructing the tracks, they will use this technique only to make the welding. Understand? So the reaction, this reaction is taking place between aluminum powder. Understand? Between what? Aluminium powder, Fe2O3, ferric oxide. Ferric oxide or what is that called as? Ferric oxide also we can call it as what? Iron 3 oxide.
Iron 3 oxide.
With aluminum, which will give you, understand, which will give you Al2O3 plus 2Fe iron, which is in liquid state, plus what I am saying, large amount of heat will release. Okay. So large amount of heat will release. So this is what will happen. So here, if we'll take aluminum powder, this is in powder state, will react with iron oxide or iron 3 oxide or ferric oxide powder. If they are heated up by burning, understanding, magnesium powder to initiate the reaction. So we are using here magnesium powder. Why we are using magnesium powder? It will initiate the reaction. Initiate means it is what? Catalyst. Do you understand, everybody? To initiate, we are using which one? To initiate this reaction, we are using? We are using magnesium. So when this reaction will start, then aluminum metal displaces the iron and it will form aluminum oxide and iron metal, which is in molten state or liquid state. So now here, if you notice it, large amount of heat will produce. Do you know how much degrees Celsius? Around 30,000 degrees Celsius. Understanding? So about 3,000 degrees Celsius, a molten iron will produce. So that is the reason this is called as, make the reaction initiate. Understand, Bahadrani? Not the faster. It will initiate the reaction. So around, it is an exothermic reaction and produces the molten metal, molten iron at what temperature, guys? 3,000 degrees Celsius around. Okay. So that is what? At 3,000 degrees Celsius, the molten iron is produces. That is why it is called as highly exothermic reaction. Is it okay, guys? Please respond. Yes. So that is what you have to remember it. So now I have given you so many examples of metals reacting with some other compounds and taking place. Now let us take some non-metals also will show the displacement reaction. So that is what we'll study now. So those reactions in which non-metal displaces another non-metal. So you can keep heading non-metal displaces what? Displaces what? Displaces another non-metal. So, but these are not present in metal activity series. Clear, guys, everybody? Now you tell me, somebody of you, out of you all, tell me, initiate means it will make to start the reaction. Understand, Sai? Basically, the reaction won't carry it out. It will be like taking time. It's like a catalyst. Understand, Sai? It will start allowing to react the products. Okay, that is what it is. Now, answer my question. As we are studying the metal activity series, hydrogen can be replaced by what elements, guys? Anybody can tell me? List out the elements. Hydrogen can be replaced by what elements?
Potassium, zinc,
potassium,
magnesium,
sodium,
calcium,
calcium, magnesium,
sodium,
aluminum,
From
zinc,
potassium to
iron,
zinc.
as well as
iron,
what? Hydrogen can replace what is the elements? Hydrogen can replace what is the elements?
Copper, mercury, zinc,
copper,
platinum, gold.
Platinum and gold. That is what you have to
platinum,
do.
gold.
Okay. So hydrogen can replace it by above metals, which is present above hydrogen, but below, which is cannot be replaced. That is why we written some examples here. If you notice it, so here iron can react with the hydrochloric acid. Hydrogen displacement or not? Which is a displacement reaction because iron is more reactive than hydrogen, so displacement reaction is carried out. Yes or no? Same way, sodium reacting with water, displacement or not? Displacement reaction. Why? Sodium is more reactive than hydrogen, so reaction will carried out. So we are going to get the products. Now, same way, let us react. Let me see who will say now. So same way, if we'll take zinc will react with the sodium hydroxide. Let me take who will say the reaction. Very, very important, guys. Very, very important reaction. So now, as we know, first of all, sodium will react with the water. Sodium will react with the water. We are going to get water. Everybody. Sodium will react with the water. We are going to get what? Sodium hydroxide, which is in aqueous state, plus we are going to get what? Hydrogen gas. Now, this sodium will going to react with the zinc. It's going to react with what? Zinc. Understanding? So NaOH. So in this case, remember, don't think that here zinc hydroxide will come. So sodium is in combined state now. So here in this case alone, I am saying you again. So we are going to get the products here. Hydrogen gas will come plus sodium zincate will come. What will come, guys? Sodium zincate. So zincate is the polyatomic ion here. So this is called as sodium zincate. Very, very important reaction. Kindly remember this reaction. This is called as sodium. What is to call it, guys? Zincate. Okay. So that is I want to say. So if we'll take all this. If you take all these examples I am saying you, metals reacting with the metal compounds or metals reacting with the hydrogen combining compounds like HCl or water, etc. Now, let us go, as I told you, now what we are going to study, guys, non-metal is replaced by what? Few examples. Non-metal is replaced by what? Replaced by another non-metal. Another non-metal. So replace means what? Displacement only. Do you understand, everyone? So displaced. So now first one, let us take very few, guys. Majority of the non-metals won't displace, very few only. So in that few, first one is chlorine gas. So chlorine gas, when it is reacting with the potassium bromide, what is this called as? Potassium bromide. Understand? So in this case, we are going to get, so here metal is not reacting. Who will react? Pradosh? Non-metal. Chlorine and bromine is non-metal. So chlorine and bromine, who is more reactive? Who is more reactive? Chlorine is more reactive. Chlorine is more reactive. So we are going to get the product. What is the product we'll get? KCl. Understanding? Potassium chloride. Plus we are going to get what, guys? Bromine gas. Sorry, bromine liquid we are going to get. Okay. Aqueous state we are going to get. So that is what it is happening. Okay. So now here chlorine is more reactive than bromine. So that reaction is carried out. I will say that elements, remember. Fluorine, understanding, chlorine, bromine, and iodine. So these are the non-metals. Only we will study the displacement reaction. In this, who is more reactive? Anybody can tell me, girls, boys? Who is more reactive? Fluorine is more reactive than chlorine. Chlorine is more reactive than bromine. Bromine is more reactive than iodine. Clear? Everyone? That is what you have to remember. Okay. So that is the reactions. Next reaction you take. Bromine is reacting with the potassium iodide. What we used to call this one? Ki, which is called as potassium iodide. Now, what is the reaction will carried out or not? You have to tell me. Reaction will carry it out or not?
Yes, sir.
Yes.
Yes, sir.
What is the product will come? 2kBr. Understand? 2kBr, which is going to get plus what is the product? What is the another
Iodide.
Iodide.
Iodine.
iodine, which is in solid state. Clear, everyone? Yes. So why I am writing, sir? Have you noticed it, guys? Whenever I am writing chlorine, bromine, iodine individually, I am writing 2. Why I am writing 2? Anybody? Because
Diatomic.
diatomic molecules. Understanding? So they all are diatomic molecules. So that is why I am writing in I2 format. But when I'm writing in combined state, why I am writing here only Ki? Because potassium valency is +1, iodine valency is what? -1. Understand? So we are going to get Ki. If I am writing KBr, how it will come? K +1, Br -1. So if you exchange, what will come? KBr will come. Tamil Selvan, have you understand Tamil Selvan? Please respond. That is what it is happening. So that is what the products will come. Same way, last reaction you tell me. So last reaction we can make one more. So chlorine gas is reacting with iodine. Sorry, potassium iodide. So again, what will come, guys? Reactants. Reactants, what will come? Sorry, products. 2KCl aqueous state plus iodine, which will come in solid state. So that is what you have to remember. So different types of displacement reactions. These are the examples. Even I have given you the examples of displacement reaction, which will be carried out by non-metals also. So this is all about things which you have to understand regarding the displacement reaction. Now, if we take one example with activity we have to perform, so that is what? Reaction between iron and copper sulfate. Can you tell me what is the reaction? Iron and copper sulfate. Iron is in solid state, will reacting with the copper sulfate, which is in aqueous state. So what will happen, guys?
Iron sulfate.
Iron sulfate plus copper.
Iron sulfate. Understanding, which is in what color? Green color.
Green.
Understand? Green color plus we are going to get copper, which is in solid state. Now, let us take how to perform this activity. So you have to understand very carefully. Now, what is the color of iron, guys? Basically, what is the color of iron? Silvery white. Yes or no?
Silvery white.
And say if it is coming in product, what is the color of that iron? If it is coming in product, what is the color of the iron? As it already dark gray. But if you are taking in a reactant side, it will be in a silvery white color. Okay, so that is what it is. Now, let us take my iron sulfate is green color, Bhavadrani. Don't get confused always. Iron sulfate is green color. Is it okay, Wa? Yes, please. Understand, Amma? That is what you have to remember. Now, if we'll take it here, guys. So, how to perform this activity? Go to the chemistry lab. Take one beaker, test tube beaker. So in this, we have to take 10 ml of copper sulfate. What do we have to take, guys? 10 ml of what? 10 ml of copper sulfate. So what is the color of copper sulfate? What is the color of the copper sulfate?
Blue color.
Blue.
Okay. So copper sulfate I have been taken. Now I will take iron nail and I will drop the iron nail inside. What I have been done, guys? I have dropped the iron nail inside. Okay, so this is what iron nail we can say. So what is the iron nail? So what is the color of the iron nail? Silvery white. Okay, silvery white color, Sai. Silvery white. Okay, Sai. Iron nail alone. Okay. Now, if you'll observe after certain time. Okay, after certain time, if you'll notice it. Now, if you'll see. If you observe the color of the solution inside the beaker, it will turns into light green color. How it will turns, guys?
Light green.
Light green color it will turns. So light green color means that aqueous state is called as what? It will turns into light green color. See, it doesn't mean that iron nail is completely disappear. Still iron nail will be present, but it will be turns into light green color. So light green color means what is the state? What is the solution? Aqueous solution.
Ferrous sulfate.
What is that? Ferrous sulfate. Understanding? So that is ferrous sulfate. Now still iron nail will be present here. Okay. So this is the iron nail. You can notice it here. So iron nail. So above it, you can notice it. A red color substance is deposited on the surface of the iron nail. So this red color substance is deposited on the surface of the iron nail. So that is only what we used to call, guys.
Copper.
Red color deposited. Red color
Copper.
deposited. That is what we can say copper metal, which is in reddish brown. Okay, which will deposit on where? Monish, which will deposit on the surface of the nail. Understanding? Deposited on the surface of nail. On the surface of nail. So that is what you have to remember. So this is what about the reaction. So here, what is reaction? If we'll just leave for half an hour. So this is which reaction? Displacement reaction will carried out between iron and copper sulfate. So that it will turns into which color? Blue color will turns into which color, guys? Light green color. After it will turns into light green or greenish color. It is clear, everybody? So that is what I want to remember. It will turns into light greenish color. So this is what we used to say displacement reaction. Is it okay, Asrita, Samaya, Karthik, Sai Karthik? That is.
Yes, sir.
This is what we used to say displacement reactions. So hope you all understand. So displacement reactions also shown by non-metals, but very rare, very few non-metals only will show the displacement reaction. Okay. So this is all about the today's class. So displacement reactions completely we studied. So if we'll take some more other reactions also, we can take. Okay. So that all the reactions will be carried out when it is only we can notice if certain changes, displacement reaction is taking place. What is the changes? Color will change. In some reactions, maybe precipitate will form. And some reactions, what is happening, guys? Some reactions, what is happening? Nobody will say. Some reactions, precipitate will form. And some what is that? Next one. It will takes place by only ionic compounds. This can be shown by ionic compounds. And these reactions are which one? These are redox
reaction.
Okay.
Redox.
Things you have to remember. So now let it be. So in special reaction here middle, iron oxide, as it was ferric oxide reacting with aluminium. So that reaction is what we used to call? What is that called as? Thermite reaction.
Thermite.
Or we can say thermite welding. So which is highly exothermic reaction, which is the temperature about 3000 degrees Celsius, the molten iron will release. Understanding? Molten iron will form. So that is why it is called as exothermic reaction. Now, sir, where we are using thermite welding for general awareness, even government exams plus NTSC and all it will useful. So thermite welding we are using in welding of railway tracks. Where we are using, guys? Railway tracks. Understanding? So, and same way, broken parts of the missions. Broken parts of the mission. We are using thermite welding. And same way, this is a large amount of heat is released during this reaction. So, which will melt the iron. So around 3000 degrees Celsius. That is why it is saying highly exothermic reaction. This is what we have been studied about the today's class. So with this, I will wind up. So till here, everybody revise well, and you have to get ready by tomorrow's class. Till here, any doubt, you just text me. And with this, I'm going to stop the today's class. Thank you, everybody. We'll meet in the tomorrow's class.